let's get started for the iPhone class today. Not iPhone. This is Objective-C. And let me start out correctly by saying the correct class name, Objective-C. And today we are covering the concept of views and events and looking at some higher level Objective-C concepts that we haven't looked at yet, putting the pieces together. Wednesday, we will have final exam review day. And so on Wednesday, we will go over everything that you'll need to study for the final exam. The final exam will be on Monday, August 27th. So this is our last week of class. So let's get started. This is actually called lecture number 7. I uploaded 6, 7, and 8 to the website today. So these are new ones. 6 will be one that I'll be going over on Wednesday, which will be a review of the course essentially. Okay, so what you're looking at, or have been looking at for a few minutes, and this is in a form of a PDF file instead of a PowerPoint, and I'm going to kind of skip around to it. I want to talk about certain things, and this is a good example here of the NS point concept. We haven't looked at graphics, but you can do low-level graphics in Objective-C as well, and it's just a matter of creating concepts from the building blocks that you have already. And as an example, what you're looking at here is the use of NS point. NS point representing a point, and we have the CG point, float, X, and CG stands for computer graphics, and it's an extension of OpenGL. So Objective-C supports OpenGL libraries, and there's actually NS to the whole thing as well for the next step for the Mac. So essentially you can create, put, plot, draw out screens, draw out animation, figures, rotate things across an axis. Everything that you can do essentially in OpenGL you can do in this interface. So what you're looking at is a type-defined structure. Well, the structure is, this is actually C code. The structure itself is holding an X and a Y coordinate that's going to define an NS point. And in an NS point, we have a pair of XY coordinates, and then we have an NS0 point that represents the bottom left-hand part of the view, the screen. So we can create an NS make point X, Y, and then we would get something like this that would appear on the screen, essentially. We can draw lines this way by 2 points and then connecting them together by drawing the points in between. We can make the point, and here's a pretty much an example of that. We can look at the NS size, essentially. So it should never be negative. We have a height and a width for, let's say, a rectangle or something that we want to create, and use an NS size, where we're going to create the object with a coordinate system. So it's a pair of height and the width. So to create an NS make size with a width and a height, as an example. You don't have to implement any of these. I'm just showing you these as ways of looking at the graphics system that is part of the library. These are all NS objects. So NS rectangle, as an example, could be defined as an NS point origin, NS size. So basically you're looking at creating building blocks where you're creating a structure. And the reason why we're using a structure on here because it's a definition of multiple variables that work together. In this particular case we have a width and a height that are working together. And we see there are CG float. We can actually use a more automated way of doing this, and I'll show you in a few minutes. But to create a window as an example, with an NS rectangle with an origin and a size, so a combination of the origin and the size representing the rectangle area. So a height, a width, an X and a Y. And then a rectangle here would be defined this way. So we have the rectangle.size.width, rectangle.size.height, essentially, giving us the components needed for that. Can you put that phone away? Yeah. Just turn it off. It's easy. There's an on-off button. And actually, just put it right up here.
Oh, well,
right here?
it's
Yes.
off. I shouldn't.
Yeah, put it right here. It's not off. Could you, here, I'll take it for you. Ask for it. I'll give it back to you when you're all done. Thank you. Okay. So what do we have here is a representation of the NS make rectangle. I'm going to pause this video for a second. Okay, sorry about the interruptions. Now I can speak freely without having to multitask. So let's see, representing points and areas. So this is pretty much an example of creating a basic function to to make a rectangle using basically two sets of points for a coordinate system and setting the origin. So representing points and areas, there's three types. There's an NS point, an NS size, and an NS rectangle. They are not Objective-C classes, as we've seen. They're structures, actually, and they're implemented as structures because the library itself is a structure-compatible library. Let me hold on for a second here, actually. Hold on one second. Let me pause the video one more time. Okay, we're back. Last distraction for today. So we have representing points and areas. So there's three types, an NS point and NS size. And here's the part here, what we're looking at. So as arguments, they are passed by value and with no star. So here we see the asterisk here, for which, because these are not actually Objective-C, these are C. And we know everything in Objective-C is done dynamically, so we can essentially not have to use the asterisk essentially and accomplish the same thing here. And so this would be the correct way of creating the statement, which would be the method to create the concept of drawing a rectangle. Because what we're trying to accomplish in here is we're going to draw this rectangle. So we're going to create a method that's going to take on the arguments, that's going to draw the rectangle. And this is pretty much what the method prototype would look like. So no need to retain or release either because they're written in C, this particular example. So unless you're using C, unless you're using Objective-C, there's no memory management functionality to it, because it's not done dynamically. So basically you can treat them like integers, essentially. So if you were doing it on an iPhone as an example, this is not done on an iPhone. This particular methods, these particular would be done on like a Mac OS X system. If we were doing it on an iPhone, we could call the NS prefix that becomes the CG for core graphics. We actually import the package for core graphics. Then we can use that. So it's called CG point, CG size, and CG rectangle, but they're used the same way. So we have a CG make point, CG size make, CG rectangle make, not CG make X, like you perhaps might actually expect. So this is just to make you aware that there's different ways of drawing windows and screens, and there are more automated ways of doing this, obviously. We have this concept of the view. The view here handles drawing in the event. So we've seen NS view as an example. And NS view is essentially the automated way through the NS library from NS object to create this with a more automated, less, drawing a point and drawing a rectangle kind of thing. So it handles drawing and events for the rectangle in the window, buttons and text fields as we've seen so far. So we can contain subviews inside of the view as we've seen so far, and the subview NS view to implement your own drawing and event handling. So here's kind of like what the hierarchy looks like in terms of the view. And this is basically to round out the information that I gave you before in terms of, because we saw the GUI components and we saw the libraries, but we actually haven't really seen the textbook information yet. It kind of correlates with this. So we've been talking about this NS window. And inside of the NS window we can see the box, or the view. So we have the NS view, which is inside of that. In here we have a text box and we have a label down here. So if we were to make an instance of this, we could say, window context view. Context view subviews in this particular case. And so we can see the text here that's on the label of the subview. So we can kind of change that, and we can go to the box. So these would all be considered subviews of the main view. And this is what this slide is essentially referring to in terms of the abstraction. So think of it more of a hierarchy of nested elements that are on the GUI. When I get all done with this, I'm going to show you an app, not an app, I'm going to show you a Coca program that does has a view inside of a view, has a web view inside of a main window view, and it has a table list view to the left of that. And so we'll see the kind of the nesting of the subviews, which is kind of the purpose of this particular drill today. So we have bounds and frame. So the NS view has two rectangles associated with it, the bounds and the frame. So the frame is the view's rectangle inside of its subview. And the bound rectangle defines the coordinates used for the drawing of the events. And in terms of the concept here, what we're looking at is now this 0.00 down here. So in terms of the drawing range, it's 40, 30. Were you here to take an exam? No. Hey, excuse. Hold on a second. Let me just pause this one more time. I hope that's the last distraction for today. Okay, so now the point here, 0, 0 is in the drawing view range of 40, 30, which is the coordinate here. So if we were to use this kind of function to define the frame, it would be an NSMake rectangle with these coordinates, which is going to be the 1, 2, 3, 4 coordinates. This is the underlying implementation of the window and of the frame, and it basically defines the boundaries. So the bounds in the frame, changing the size of the coordinate scale, 1 to 1 as an example, would shift the entire rectangle over in terms of the adjustment. So we can draw inside of the frame once we have used it. And the reason why you want to be familiar with this concept of there being a coordinate system that is associated with the frame is now we can actually move the window, we can adjust the window, we can move the subviews inside of the window or the frame, and we can pretty much position our GUI items using the coordinate system if we want to, rather than using, let's say, I don't know, the interface builder or something of that nature. You can do it programmatically, which in some applications it might make some sense. So drawing, and this is just basically an introduction to the concept here. So to draw the rectangle, we would basically, we're looking at the NS rectangle, and we're going to create a method here called draw rectangle, and so draw some things. So we can define an NS view subclass, and then the rec is the sub-rec of the bounds that needs to be redrawing. So you're allowed to skip things inside of it that you don't want to do, or you don't have to, don't call it yourself. It won't work actually. So it's going to be essentially drawn by the graphics system. So in terms of redrawing, you can't call the redraw directly either, but you can do this. So this is going to be view set needs display yes, to reset the display after you've drawn something on the display. So what you're doing is essentially defining items like rectangles and circles and things, and you're putting them on the display and redrawing the display. But you can't call it the view itself directly. You actually have to go through the objects that are in the hierarchy to actually have that reset. And there's built-in methods for that. So in here, set needs display yes, which means essentially redraw it, or needs display in rectangle. So you tell Coca to redisplay the proper portion of the view, or the particular subview that you're working with, essentially. Alright, so graphics. So the NS bezier path, if you're familiar with CG or some of the computer graphics stuff, this stuff will probably make a little bit more sense to you. If not, don't worry about it. It's just an orientation to the graphics systems, graphic package and libraries. This is all part of core graphics, by the way, which is what the CG stands for. So the collection of path elements, a line segment, and curves used to represent boxes and circles and lines and arbitrary vectors and shapes. And many drawing directions or strokes, so you can draw the outline or it fills in the interior by calling basic function calls. Clips the drawing to the path. And then this is something you probably have worked with already, is the NS color, which is part of the core graphics package. So the default colors here in terms of NS color, and you basically would go online. Actually, you could go online and figure out essentially the rectangles, the squares, the circle, ellipse, all the different NS objects that exist, and then as well all the different colors that might exist. And well, these are just predefined colors. Instead of using an RGB scale, you're going to say red color, blue color, yellow color. And it's definitely going to be particular in terms of the implementation, and also the version. This is Objective-C 2.0 compatible. Some of the earlier versions didn't have any color component. It didn't have as many color components to it. So some default colors. Here we have NS color, red color, light gray color. So you can make your own using NS color with collaborate red. So this would be a green, blue, and an alpha as an example. Can you please assist? Yeah. Here, right up here. Oh, okay. So set color for drawing here. Color set would basically set a color. So here's a bezel path plus an NS color. So path with rectangular R, and NS color, blue color set, and then path fill. So we're setting a path of the rectangle here. And this is basically making method calls to set the rectangle and then to set the fill color of the rectangle, which comes in handy. Here's another example, and this is the sample code that would create this particular. So here, in terms of the path with an NS color, we have the yellow on the outside of the object itself, and so the NS color yellow would be on the rectangle itself. The fill is set to the blue. So in terms of the components, so the NS color blue color set, NS color yellow color set is going to be the path fill. And so what we're doing is we're making one call to set the color, the other one to set the path, and then path stroke. So path fill is essentially going to fill the path of the rectangle object, and the stroke is going to fill the lines of the rectangle object. This is all about this particular CG object, which is this rectangle that was defined. In fact, here's the path with rectangle R. Well, R, this is just partial code. This is not the whole thing. We'd have to define what R was in terms of the coordinate system. But you can probably see the concept here in terms of how the NS color is being used with the rectangle kind of just built-in shape, essentially. And here's a set of lines. So let's see, this is thicker here. The line here is thinner. It's the default value of like, I don't know how many pixels it is, but it's set on something by default. This next example is just essentially set the line width to 20. And so the 20 is going to make a thicker line. So it's the same code over again, but setting the stroke color to yellow color instead of black, which is the default system. So by default, we have that color configured, and then we can change the color. So why do you want to do that when you can use the interface builder to do this? Well, maybe you're not using the interface builder. Maybe you're writing Objective-C code and you're extending the core graphics package, and you don't have a GUI editor. Then you got to do it this way. Essentially, the GUI editor is doing this for you, setting the parameters essentially in the XIB file for you. So you can actually do this programmatically as well. You can have certain things. Let's say, for example, you're filling out a form. This is a practical example here. Let's say you have your user's filling out a form and they left something empty, or they put the wrong value in it. You can certainly outline the form location and make it red. This would be an example of one of the usefulness of it. So it works with the windows, works with the text boxes and the labels and all of the GUI components, essentially. This is just essentially an example of a rectangle that was being pathed, but it works with everything in terms of the concept. So we have some convenience methods that work with this as well, and this would be a fill rectangle, stroke a rectangle, which means paint the line a different color. Stroke the line from a point. Here's the point 1, point 2, which is basically going to create a line between 2 points and connect them with a stroke, and then essentially you could color the line if you wanted to as well. So text drawing. So we have a string that's inside of a text box, perhaps, or a label, or we just have the string. So the string doesn't actually have to be part of a GUI component. So here we have an NS mutable dictionary. We saw dictionaries actually in the last, we saw mutable dictionaries in the last class meeting, I believe. And so here we have attributes that are being set. So we're going to create a mutable dictionary. And we're going to set the object's NS color to red color. Okay, and for the key, the foreground color, it's going to be the attribute name. So, and here's the string, a string. So we're going to draw it at point, and then we're going to draw it essentially at NS0 point, which is right down here at the bottom, because this is 0, 0 of the rectangle. If this were the window, I should say. With attributes, and these are the attributes. And the attributes is basically set color to red. the text color to red in terms of the draw. So it's essentially a way of drawing a string. So most people would take the interface builder and drag something over there, put a label on it. But if you weren't using it, this is the other approach that you can take to it, essentially. You can also, the other thing too is you can create GUI components that don't exist in the library. The library is just nothing more than predefined objects. So let's say, for example, you wanted to create your own library component. Well, then you would use these techniques to essentially define using the graphics system, the core graphics library, which is the lower level implementation of all those items that end up in the library. So you create your own definition of a line, your own definition of a box or something, and give it some different attributes and qualities. So here's an image draw as an example. So NSImage as an image draw, image name Bob. We're going to call it Bob. And the image draw is going to be at this particular point, and take this image size and essentially assign this particular file, fill it into the image box. So, is he done?
Yeah.
You're only taking one? Okay. Not taking both? Oh, hold on one second. Okay, I'm back. And so this is an example here, and we've got the image that's showing up here from the image, and we can set the image size, we can set the composition, we can copy it in, a fraction of its size here. So we made the image kind of small, actually, in this particular case. On the phone itself, we'd use a UI view instead of an NS view. And this is relating iOS with the OS for the library that we're working with. And so whatever, if you're in the iPhone class, whatever it is that you've learned in terms of the UI view, it's the same as the NS view. So everything on the Mac Coca system is NS. Everything on the iPhone or the iPad development is UI. And you notice that quickly when you go into the library and you just switch back and forth, create two different projects, and just start switching back and forth between the projects. And you see UI, NS. It's all the same components, but it's coming from two separate libraries, which is why there's two different names. So UI color instead of NS color. There's no UI bezel path, but there are low-level C calls to make bezeler paths. I'm not saying that correctly, probably. And the drawing is much slower to avoid custom views. So avoid custom views on the iPhone. The drawing is much slower. You're going to get more drawing capabilities on a native Mac OS X application versus an iPhone. In the iPhone, you're probably not going to do anything of that nature. You're going to have it. You're going to use the preset libraries, and don't create anything yourself because the drawing is kind of slower. So a word about events. When the application first loads, it loads up what's called the NS application. This is on the Mac OS X system. iPhone and iPad have their own life cycle to them, as we've seen before. They have different stages in which we have the view did load and the view did unload and all of the other things that happen, and we have the different events that we can set in terms of what happens from those methods. Not quite the case. In a Mac OS X application, we have a main, believe it or not. And we still have main actually on an iPhone. It's just hidden. It's hidden underneath the interface. Nobody's ever used it. It's usually an older, you don't normally program with it, and it's an older file project types. The newer ones don't actually have it, but the newer ones, essentially for the OS X, still have it. It's part of the main concept. So main's going to make any instances of objects, and the first thing it's going to do is create a window. So actually, if we take a look at a project, because I keep forgetting I actually have it here, let's just look at it. We can sort of see, in fact, I'll just create an Xcode project, and I'll do one in the Mac OS X here. So this is going to be an application. Single view application. Oops, we want to do down here. I'm sorry. Command line application. And let's do Coca. Coca is actually the GUI graphic library. So if we're going to create, and you don't have to use it for your assignments for this course. You don't have to use any GUI. It's all command line programs, by the way. And I've had students ask me that. So I'm going to call this my test. And it is going to be a document. It's not going to be a document based, but I'm going to use core. No. It's just going to keep the default settings. And basically, I want to show you the components that are associated with it. If I create the project, what I'm going to notice is that over here, I've got. Oops, I open it back up again. I've got main menu.xib. So it's going to be associated with the main component. And under the supporting files, I have a main.m. And the main.m, if I open it up, is making an instance of application main. So it's working with NS application, and it's the main that's associated with it. Probably not going to use it for very much. Instead, what we're going to do is put stuff in the app delegate up here. If we run the program, we get a basic window. It's the application. And then we put the views inside of the window. So I'm running it right now so you can actually kind of see. Build successful, which is good. And here it is. Here, this is the whole application. It's hello world. So I could essentially put the code that I just showed you a few minutes ago, draw something in the window if I wanted to. Draw a rectangle, draw a couple of points. One thing to notice here is that we are importing coca.h, which is interesting. Because we can also use foundation, which is a higher level, but it includes coca, excuse me. So, all right. So it manages the main. So the NS application itself manages the main run loop for the application. So the running of the system. So in the NS application, we're actually looking for events that are going to occur. In a non-iPhone iOS environment on a Mac system, the events are going to be a mouse or a keyboard, essentially. We don't really have touch screens yet. Although I can perhaps see in the future we'll have MacBooks with touch screens. Who knows? So it dispatches events to the relevant objects or class NSResponder. So this is where the NSResponder comes into place. And the owner of main menu.nib, well, this is actually XIB in the current system. But they used to be called nibs actually in the old days as well. They pretty much are accomplishing the same task. So there's an application life cycle that goes along with the Mac OS X application, the same as the iPhone. Can you please shut that door? It goes along with the same. This is the most distracting class that we've had all term. Can you shut the door? Thank you. So we can run the loop here, wait for the event, handle the event. In terms of the application lifecycle, what we're doing is essentially having event-driven programming. So kinds of events that might occur, some sort of input from the user, some mouse up, mouse down, mouse moved, keyboard pressed, released, drawing tablet events. If you hook up a drawing tablet to the computer, yes. If you're running it from, and we've yet to see products like this, but eventually we're going to essentially have the touch interface that will be working essentially the same on a Mac computer as it does on a tablet. So eventually. So the event dispatch, or the mouse event, so the Windows server sends the event to the NS application that owns the window under the cursor. So if void send event NS event, the NS application sends the event to the appropriate NS window. So we can send events from within the application, we can catch events from within the application. Slightly different format than working in the iOS environment. So in the iOS we get it automatically, and we have IB outlets and IB actions, and we work with that essentially as an automated higher level API. We can actually do the same thing in the current version of Xcode. We can also take and capture the events manually if we want, which is not quite as efficient as using an IB outlet or an IB action. So NS application sends the event to the appropriate NS window. That window will find the appropriate view using a hit test on the content view. So mouse events. So depending upon the type of the event that's occurring, a different method is called on the NS view. This is a mouse down event as an example, a mouse up, a mouse drag, a mouse move, a mouse enter. So actually kind of think of the Microsoft Foundation classes, if anyone's ever worked with Visual Studio, where we have the resource editor and we're looking at events and we're programming usually methods to capture events. And the concept being essentially very similar, slightly different syntax because we're working with Objective-C and we're not working with C++. It's a very similar concept, however. So in our mouse events, we have the NS point window position. It's going to be equal to the event location and window. So we're sending the location and window from the event to say, well, where did that occur? And if it were on a picture, for example, it could run a certain command or something to capture the event. Or the view position to set the point on a window position, so say from view nil. So. And if the event has a click count is equal to 2, then we've basically captured a double click. So we can kind of take a look at that. And then drag X, drag Y, dragging things across in terms of capturing a drag from a mouse event. So delta X, delta Y. So, and then the event dispatch essentially for key items or key events. So instead of the window under the cursor, the keyboard events go to the window, key window, so NSApp key window. And then for each window, there's a first responder. And this is where that terminology comes into place, this first responder. First responder is essentially it's not the dispatcher. The dispatcher is the automatic system that's going to tell the system that the event has occurred. The first responder is going to be your action that's associated with it. So it's basically the terminology of being dispatched and then being responded to. So first responder, in fact we see this in Xcode as well. We see it on the interface builder, we'll see first responder. Well, the first responder is where you're going to essentially look at in terms of events. So your gesture controls and stuff are going to be added to the window to essentially sit there and monitor for particular gestures, for particular activities to occur. And then the first responder is going to deliver that activity. So the first responder window, first responder. So in order for the window to become the first responder, it must return yes, except first responder. So in the first responder, we can say reset first responder. That will take away a keyboard as an example, or take away any input that's from keys that are entered, clear out buffers and stuff like that. So key events and mouse events are pretty much what we get on a Mac OS X system. So in terms of the key events, there's two different types or different methods on the NSResponder. We have a key up and a key down. So it's like a NSString, let's say for example a character, we can event characters which may give us the characters of the keyboard that was pressed, the key up or key down, and an unassigned modifier for modified flags we can set in here, and then we can basically set a command key mask and set is it equal to a particular key, and then say, well, if you press this key, do that. If you press that other key, do this. So you can essentially make, let's say for example, the function keys perform something within your application. And if the first responder was the main window, then the function keys might actually open up menus or something of that nature. So there's more automated ways of doing this, obviously, but it's just showing you the lower level kind of older fashioned way of responding to events and keys. On the iPhone, there's no keyboard and no mouse events. In fact, we don't have the same abstraction. Touch events are instead, so we have UI event that contains a collection of UI touches. So remember when we right mouse clicked on the GUI item like a button as an example, and we saw touch down, touch inside, touch upside, I don't know, all those touches, those are the events. And so we say look for this event, and when this event occurs, we attach an action to an outlet, and the outlet is essentially going to be the event because it supports a multi-touch. You're going to actually do this, well, you can't do this. Let me rephrase that. You can't do this on a Mac application. You can only do this using the UI touch controls. So here's our touch event where our touches begin, our touches move, our touches end, our touches canceled. If you really want to see this in action and you want to see it on an iPhone application, go to the DA workshops, and let me just pull that up so you know what I'm talking about. I put together some apps for a DA workshop last weekend. Apps. Oh, let's go here. Probably in workshops. Let's just do it this way. There we go. So workshops DA apps.html, which is the URL I just went to. And what you're looking at is image touch. All of these are actually going to be demoing those touch events. So the image touch and the move image, these two examples right here, which are done for you right here, touch me and touch move, are going to be showing you essentially the implementations of these particular events that are in this lecture here. So, and it's the touch begin, touch move. So you can actually capture what happens if the user touches on something and then drags it to the right or drags it to the left. Then you can move that GUI item around as an example. So, or cancel the touch. So event all touches returns all of the touches in a multi-touch sequence. So you can essentially queue it up and then be able to deal with each one of the events as they occurred. So, and the touches are just touches associated with particular calls. So if you're only expecting one touch, and you get it with touch any object. So here's the UI touches, sending it on any object, which means return the object that is particularly that's of the touch event. So if touch's tap count is equals to 2, then handle a double tap as an example. So going back to our other example, it also picks up CG points. So the CG point A, comma B, where A is the touch previous location in the view, and then B is the touch location in the view self. Returning self, sending self as a parameter to the location, which means on my display, give me the location where I've touched A and B, and then I can connect a line or something, or I can space something out, or I can drag something from one location to another location, which is what that touch me is actually doing. It's taking an image and moving it on a touch from one location to another location by taking the CG points and then moving it from this point to this point. So. And then turning on a multi-touch. In fact, I'm probably, when I'm all done here, I'll bring up that application so you can sort of see what it looks like. And then that might give you some, realistic, looking at slides or, documentation doesn't normally can confer the same kind of meaning than seeing it turned into an example. So in terms of turning on a multi-touch interface, self multi-touch enabled is equal to yes. We'll see that implemented. You're going to probably put that in the app did load or something, and if you're going to create an app out of this, and then detect the multiple touches, the multi-touch interface. So what I'm going to do is actually download these two examples here. I've got Touch Me here, saving it to the desktop, and Touch Move. Just so you can see them. We're not going to go through the application builds. If you wanted to, you can look at these particular ones here. It's for an iPhone, iPad interface, not for Coca, but it's going to be the same concept as in both interfaces, actually. So let's see, we have Touch Me and Move. So I'm going to go ahead and actually can sort of see how these examples open up and work as well. So I'm unzipping them both. And let's look at Touch Me first. So if I go into Touch Me, there's a monkey on there. And the monkey, when you touch it, is going to, well, I'll show you what it does first. You can load this up and modify it and sort of play around to see how the touch controls actually work. You can do this in a regular app that's not not an iPhone, but if that were the case, you'd have to pick up the mouse events because we don't have touch on a Mac OS X system. But most of you guys are taking both classes and you're looking at Objective-C so that you can program for the iPhone. So touch begin, I pushed down my mouse actually. So because I'm working with a simulator, it's picking up my mouse because I don't have a touch screen, but this would essentially be a touch. So this is a drag. So I held down touch to stopped, I let go of the mouse. So if I push down on the mouse button, this is my left button, it says touch begin. I'm going to drag it now, move it a little bit, it says drag detected, and then touch stopped. And then this event here is going to move my window, which is what it did a few minutes ago. So it's kind of a primitive application, but it's looking at the implementation of those methods that we just looked at. So if we take a quick look here, the project has those images. I'm just putting the image out on the canvas. If we take a look at the .m file and the touch events, so it's looking at touches with event, touches with event. So here do we have touches begin, touches canceled, touches enabled, touches moved. These are the ones I just showed you in the lecture a few minutes ago. And so what we're doing is we're just saying, changing the label text when the event has occurred. So it's nothing more than essentially detecting. So touches with event, UI event, taking when this particular event occurs. Well, what does this look like over here? Well, we have the view, the label, and the image that are properties here with the interface. And we're getting the automatic system that's detecting these things for us. So if we look at the XIB file, we essentially just have, let me open up the side panel here. Open up the editor over here. Actually close the side panel. we can see that we have the window that we're using, and we're going to detect the touch events on the window. And then we have the label, which is being changed, and then the image itself. So it's nothing more than, in fact, there's no corresponding code here for any IB action. We have the IB action of clicking the button, and the button's going to essentially do something for us automatically. And if we take a look at that, actually, switch to here. The push to start button is actually taking and beginning an animation, and the animation is essentially going to set here a little duration of 0.5 and begin from a current state, yes, and then animate repeat 3 times. So it moved the window up and down, if you remember, 3 times. And the animation itself just transformed the window, so it's transformation to translate the window position. And it positioned it down here. So you can kind of see here we are using the CG, the core graphic library call to affine the transform. So set a transform to transform to, essentially, and transform to is our translation. So it took the bottom 2 coordinates of the window, because we start in the lower left-hand corner. So if we run the sucker, we'll see. And we're making it -60. We're changing it here. So this is 0, 0. So now 0, 0, 2, 3. Because 3 is it's an odd number, didn't go back. So moved it up, moved it down, moved it up, moved it down. But it's doing it, move it up, move it down, move it up, or move it down, move it up. Anyway, long story short, it's stopping on an odd. If I made it run 4 times, it would actually go back down where it was supposed to go. But it's adjusting it by -60, bringing it up. So, which is a simple animation, actually. But this is how you're going to get those little simple things to happen in terms of an iOS application or in terms of a Mac application. You're going to be playing around, and the purpose of this is just to show you the CG core graphic utilities and the mouse events, or the touch events that occurred. This other example is kind of interesting as well, and you can more than welcome to download the code and play around with it. It's called Touch Move, so it's going to pick up a starting location, and then it's going to pick up an ending location and move the item from one spot to the other spot. Well, we're going to need to use the same libraries that we've looked at, or that I introduced to you a few minutes ago in the lecture. So I can move. So now I'm touching the image and I'm moving the image. So it's going to stay at whatever location I drop it at. And if I take a look at the code real quick, it's just a window with an image on it. And the property is the UI image view that's being put on there, and there's no action associated with this. Instead, here's the CG float, if that looks familiar, hopefully. And the distance between the 2 points was calculating from this point to this point so that we can move it. So it's taking one of the coordinates of the system and it's rotating. Is that my other person? So he's the last of it. Yeah. No computer. He has to leave everything inside here. So. In terms of the implementation, here's the distance from point. And we have, and as mentioned before, this are just, instead of CG points, just point, because it's just an integer, it's not using Objective-C. So we have float x and float y is going to be 2 point, this x and this y. So the from and the to, basically taking the starting position and the ending position, and then locating the new one. The touch cancel is just basically going to, when I let go of it, it's going to stop the touch capturing while it's touching, while I'm pressing down on it on the touches. It's changing my distance, so it's moving me away by a certain increment as I drag the image across the screen. So we can see sort of an implementation of the code that I was showing you in the earlier part of this lecture, which is the reason kind of like why I was showing it to you. It was just to give you some possible implementation details and just an example. Fortunately for you, you don't have to program with any touch controls or with anything for this particular class, but if you take it on a little bit further, you're going to eventually want to start working with some of the graphic capabilities, the drawing capabilities and stuff, to make it a little bit more sophisticated. And they're the same, more sophisticated apps. Here's the touch ended, the touch began up here, touch move, touches move. So it's pretty much the same library calls and the same methods and method implementations as I showed you in the lecture. So And I also put together another example to show you today. It's called the tab browser. This is a Mac OS X application, by the way. It is not an iPhone application. This is the one I originally intended to show you today to kind of put the pieces together in terms of the NS application and the NS window, so you can sort of see how it goes together. So what we've got here is an NS window, and inside of the NS window we've got a view, and the view is going to be a web view. So it's going to show up a website, so location, and we have a scroll table view here, which is going to be another component that I've dragged from the library and stuck on the canvas. So if we run the program, we'll see what it looks like first. And this is not an iPhone, this is a Mac application. Oops, let's clear this a little bit so I can see what I'm looking at. Here's the window, it's called Tab Browser, and I put this actually out here. It is out in the Objective-C tab browser. It's in the core code examples. Because you might want to play with this one, actually. It's kind of a fun little application. It's just a web browser, essentially, with some links. And the lecture that I went over today actually was uploaded here. 6, 7, and 8 are new ones. I went over 7 today. 6 is going to be a review of Objective-C that I'm going to go over on Wednesday. So you might be interested in previewing that if you missed the class on Wednesday. But so what does the application do? Well, if I click on the links, it's going to capture the click event. So this is basically a demonstration of all of the concepts I basically tried to show you the text for. But this makes, I think, a lot more sense than reading off slides to you, or it's picking up the click event, and then it's showing in a web view the 3 URLs here, and it's using a mutable array, actually. Now I probably could have resized the window to, but you see we don't actually have any controls, but it is a web view. I probably could have resized the window perhaps to make it full screen when it opens up. But that is a Mac application, and let's go take a look at the code real quick here. If I can bring it up. There we go. So let's see. What is this? My test. I want to get rid of my test real quick here. Stop. I have let's open up this guy. Thought I had this one open. I do have it open. Okay, so we can see we're using the Coca library, and we're also using the WebKit. So because we're using a web view element in here, which is a little different than the iOS environment, because the iOS environment already has it in the library, so we don't actually have to use it. It's part of the foundation classes, but this is not foundation, it's Coca that we're working with. So we're making an instance, and this is the mutable array. I'm going to call it URLs. And we have 2 IB outlets here. We have the web view, and then we have the NS table view. And the NS table view is the one on the left. So if I bring up my main menu.xib file, and I do the same thing as I do in the iPhone app, I click on the editor, I can sort of see, here let me make this a little bit smaller. I can see the 2 components here. This is the web view, which is the side part here, and then we have the NS table view over here. So we just loaded it essentially from the library. Just come down here and type in table view, and here's our table view essentially. Put a table view over here, and then in our implement, so this is the extent of the coding, which isn't really that much. So if I look at the controller.m file, I see the implementation. Again, if I compare this kind of like with the iPhone environment, in the iPhone I'm going to have view did load, view did unload, and I'm going to have all those different things in between. And what you have here is the init, if you remember the initializer. And so in here I'm going to have a calling super init, and now I'm going to say, well, this is that mutable array that I created. So the URLs are going to be, well, let's assign it a mutable array, alloc here, and then we're going to add this object, and we're going to add this array and this array and this array. Excuse me, this address and this. This is how I'm getting those addresses to show up. And awake from nib, which means essentially when it opens up, which is going to be a slightly different part of the life cycle of this. It's going to the table view is going to register for dragged type, so it's going to essentially put the array items. So here's the NS array with object. Essentially populate it set the dragging source. Actually, it's a good point here. Let me see something real quick, actually. I still had it running. Stop. See how it drags? It's actually picking up my click events, but it will essentially pick up a drag as well, which is I forgot to show you. Which is interesting because now we see the plus next to it. So it's a more automated kind of way of working with the interface. But the drag event is in there, which is only working because of this piece here, which is essentially setting our drag. So set dragging source, operator mask, set dragging types. Well, the dragging type, the drag is set on the NS array. And so then we have an NS number, which is going to be number of rows in the table to keep track of that. Well, that's just going to be count, set a count on the URLs. You can set a count method to the array, mutable array, to get the count, essentially. And then there's the table view itself in terms of its initialization, so objects from the view table. So there's going to be a row for the row index for each one of the views, and set the row index essentially. And then on the selection did change, if the selection changed, then essentially register that the table view selected row is going to be on a certain row. So it's basically picking up the click for this. It's not running a click event, it's running a selection. So depending upon what row, and we get, because it's a table view, we automatically get information about what's selected. And we can automatically select an item, which this program doesn't do, but it could essentially load up the first URL. And so if you wanted to, you can actually just kind of pre-populate this with a bunch of URLs that you use a lot, and just switch in between each one of them. It's just a regular web view, essentially. And so continuing along here with our table view, accept a drop here, which is going to essentially perform the ID for the drag info and essentially load the dropped URL into the web view. And then NS pasteboard, essentially from a drop, from a cut and a paste. So, and then the drop operation here as well. So it's a nifty kind of app, I should say, but it's demonstrating the things I showed you earlier in the NS window lecture. So. Oops, let's stop the event here. And you can actually download that. It's called Table Browser. It's because it's using a web browser with a table, essentially. All right, I'm going to throw this away here. So the other lecture for today was number 8. And I just kind of, now, I don't have an example put together for this, but it's basically demonstrating to you, because we did this with the iPhone application, I believe. Or no, we did this with Java, actually. We set up a notepad with Java, and we saw how Java worked with the file chooser. This is the equivalent for Objective-C in a non-iPhone, non-iOS environment. So this is a native Mac type architecture. So files and archiving. So to work with files or persistent data, let's just say, as an example. So we have NS user defaults. So that's simple to use. Yeah, this is very simple to use. In fact, remember, if you remember the file chooser options with Java, this is as easy, if not probably easier. Just one big file, and supports property list types. We don't get, in fact, we don't get the same types of persistent data in on a Mac application as we do, let's say, in the Java environment, working with the Android as an example. So it only supports a simple property list types. And if you want more features, well, you just add them yourself. You can extend the libraries, actually. So file tasks include finding the file path, user-selected files, internal application data, saving and loading file data, text files, properties lists, and custom objects, essentially. So in terms of finding the file, there's an NSOpenPanel. And that looks like the file chooser, actually, that we get in a Java Swing application. But it's NSOpenPanel. So we make an instance of the object, and it opens up the file open panel, which is why they didn't call it file open, I don't know, but it's open panel. So it allows us to select files as a file selector. And then we find the file, and we use from the NSOpenPanel, and then we create a file. So we have the panel as an object, and then we open the panel, And then we begin the sheet for directory, and we can get the directory, the window, all of the information associated with it. And then capture what was being clicked on. So in terms of finding the file, the NSSavePanel is for a save. So we can open the panel, opens up the file chooser, if you want to call it that, which would be equivalent to the swing terminology. NSSavePanel is the one that's going to do a save as and save. And this is all built-in functionality by the operating system. It's the file IO system that we're looking at. So we can also get at the information, get info regarding the file as well. So in terms of the NSOpenPanel here, I'm not going to go through the code because it's not going to make any sense to you. But you can certainly download this and use it as an example. It should, if you cut and paste it and put it into a project, it'll run for you. But looking at the events that OpenPanel did end, it opened up, a file was selected, a file was chosen, finding the file with the NSSavePanel. Basically the same concept as the open. Finding a file for application support. Any other files associated with the application should go in the library application support your file, your app, excuse me. And then use the C function and a search path for directories and domains to find it. So you can actually use all of the C file IO commands as well with opening files. After you've opened up the file, you can read the bytes, you can read the streams and stuff like that. So use the NSFileManager to create your subdirectory. So here's an NSFileManager. So it's just an object of the file manager that's going to essentially bring up the same file manager that you have that you're using with all of your other files and all of the other applications. So if you haven't noticed, most of your apps that are, most of your applications that are running on the OS X all use the same interface because they're all pulling file open, file save, dialogues, and that file manager. So the NSFileManager creates, deletes, moves files and directories. And you're just making an instance of that object for your program, loading it up. So set attributes and make symbolic links, supports iterating through the file to the directory to see if it's there. And then we have application support. It works along with the NSFileManager. So here we have the getting the paths, setting the paths to an object, setting the application support as a string. So then we're basically going to load an application, or save your application, or do something with a particular thing. And we also have NSDocument, used to create document-based applications. So handle saving, loading, undoing, painting, and some of the window management that are associated with documents. So saving and loading file data from within your program, one of the most easiest thing to do would be using a text file. So actually you could read and write to a database as well, but if it's just going to be like a log of information, you can initialize it from a file. So here's an NS string that is created, and then the string is going to be compatible. So in it with contents of a file. So you take, essentially this is the way you're going to automate it. So you pull the contents of a file from this file here, and you're adding it to the string, and then you're going to use the string, and then eventually you're going to write it back out to the file. To save the file, you're going to say write to file instead of initialize with contents of a file. And you're using a string for that, which is the compatibility for it. So collections of property list objects. So if you have an NS array or NS dictionary of property list objects, you have instances of NS data, NS date, NS number, NS string arrays. So you can use a write to file automatically, initialize with contents of a file, ways of automatically doing it. See the NS property list serialization. If you look in the documentation for the NS objects, you'll see a lot more. So there's a few other classes as well, various different ones to support the loading and saving of files. Don't reinvent the wheel, use the classes that are available for you. So look in it with file contents of file and write to file methods, and you'll see a bunch of information. If you go to the developer.apple's website, you'll actually see all of the nitty-gritty details of all the methods that are associated with these objects. So some classes might be NSImage, for example, or NSData for saving and loading files and images and stuff. For reading NS data, represents a chunk of binary data, so you load the file with initialize with contents of the particular file. You can load a URL the same way, actually. You can take and read in the URL using an NS URL. essentially, as a string type. Read it in, parse it out, and actually take the file and manipulate it. So you can do like maybe a web search or something. You know, search a page to see if something is on the page if you wanted to within your application. And then load from a C array in this example here, loading it for the bytes from an array. So, in terms of loading the NS data, many COCA classes support loading from NS data. So NS data is actually an object type that holds information, so you can put it in an object NS data, then load it, read it, save it, write it out, do all sorts of things with it. So images, we have NS image alloc, sounds, sound quality, sound like bytes, PDFs, these are just some examples essentially. Any document, movie, video, audio, all that stuff is considered data. It's all in files. Anything that you could possibly store in a file, you can load in an NS data object. You can generate NS data objects as well. Many COCA classes can also be turned into NS data. So the attributes text, for example, an RTF file here. So we can RTF from range of attributes. PDF files for data representation, and also images, so image representation. So writing it out, it's essentially the same, the exact opposite of reading it in, but it's essentially the same concept. Once you have the data, you can write out to the file by writing write instead of read from file, or read contents from file, it's write to file. And you're writing to file while you're loading it on the data element that you've created, the data object. So the objects are property lists objects, meaning that you can read and write from them using NS user defaults, user dictionaries, NS arrays, any type of object actually, it's compatible. So. What about custom objects? Well, you can just create your own if you wanted to extend the libraries out. NS coding is a protocol your class can implement to enable archiving and unarchiving. Archiving, creating compressed files, archiving files. So a protocol specifies a set of methods your class must implement. They're like Java interfaces. You've seen those. You know what protocols are. We've actually covered those already in the course. So we have coding, NS coding as a protocol. Here we include the protocol signification to say that we're going to use it as a protocol. And then we initialize with color, and then we call coder. So we can use coder. So encode with coder to create, as an example, a key for the encoding for your archive, like a password or something that you might want to put on there. And if it's a subclass that implements NSCoder, you can call super NSCode or coder. So here's encoding it with an author, title, chapters, a call number, some information about the objects itself. So I'm actually not going to go through this because it's kind of dry. Just like the first lecture. It's just giving you some examples and a little bit of exposure essentially to using the protocols to implement the functionality that you're looking for. So saving and loading the NS coding objects, archiving it. You can download this. It's this one is called number 8, and you can read it on your own and implement it. I didn't put any examples together for this one, but you can sort of see where it might come in handy in terms of being able to see. You're not going to learn how to program from looking at slides. You're going to practice with it. So it's a nice, I put them up essentially for a nice reference source for you to get more information. And just so you know where they're at for this, this particular instance here, they're going to be located here. I probably should have labeled them something else, but what I just did is tonight we went over 7 and number 8. So we're going to go over number 6 next time, because I want to combine that with the final exam review. So what I've done tonight is kind of hit some miscellaneous topics that I haven't hit yet. We've actually hit everything, so we can actually kind of end a little bit early tonight. So unless there's questions or comments or concerns. I've actually got the exams written, but I want to wait till Wednesday to go over them. These guys are my beta testers right now. Let's see how they do on it. So, questions? Then I will see you all Wednesday for the official final exam review and the review of Objective-C. I'm not going to hit everything, but I'll hit the main topics in terms of what it is you need to know. So, okay, that's all for tonight.